Hello students. So today we will discuss about more about index mechanism. Already we have studied the primary indexing. There are three types of indexing, means index mechanism or index technique. There are three types of index mechanism or index technique, and why this index mechanism is added to the sequential file organization, that thing also we have discussed. So index mechanism is added to search fast, to searching operation very instantly or very fast searching. We are adding the index mechanism in sequential file organization. So index mechanism normally there are three categories that we have studied. So yesterday or previous class we have discussed more about the primary indexing, where the index file was created with a sorted data file, and by taking primary key or key field for creating index file, means index file was created by considering the primary key of the data file. Again, the data file was in sorted order. So sorted order with data file and primary key are used for index file. Okay. That means every record in data file there is some index entry in index file. So number of records in data file is equal to number of records in index file. That thing we have discussed. So in primary indexing, this is your primary indexing. In primary indexing, so main file is in sorted, and index file was created by considering the primary key. Okay. So primary key plus sorted order of the main file. But in case of cluster indexing, that is second category of indexing, that is cluster or clustering indexing. Today we will discuss about the cluster indexing. Okay. So in primary indexing, what happens? Data file was sorted data file plus primary indexing, primary key was used for index file. Data file was sorted and index file was created according to the primary key. But in case of cluster indexing, data file is also sorted data file in sorted in specific key value, plus index file is created by accepting a non-key attribute or non-key value, by non-key value, and this is the index file. So in the cluster indexing, for each and every record of the data file, there is no index value, means it is dense indexing. In case of primary indexing, it was a dense indexing, because every record in the data file has index entry in index file. Means number of records in data file was equal to number of records in index file. But in case of here, number of records in data file are not equal to number of records in index file. So clustering means some common field, because we are considering here non-key attribute. Non-key attribute may be duplicated. So for each and every record, for each and every record, index entry are not created in case of cluster indexing. Okay. For each, that means number of records in index file not equal to number of records in data file. That means for each and every record in data file, the index entry are not created. Okay. So that means the index file will be maybe less. In index file may be small. Okay. So now consider here the index file was created according to the non-key value. Non-key value was used for creating the index file. Non-key values are used for creating the index file. And again main file is sorted. Again main file is sorted. Okay. So the cluster indexing, we will discuss more about the cluster indexing. Now let's discuss more about the cluster indexing. The second type of indexing is the cluster indexing. So in cluster indexing, index file was created by considering a non-key value, and main file was in sorted order. So if the records of a file are physically ordered, on a non-key field, that does not have the distinct value for each record. Okay, so that field is called the cluster field. Means whenever we are arranging F records and there is some non-key value, means for each and every physical record are ordered according to non-key. That means they are not distinct. All records are not distinct. There must be duplicate, because in non-key value can be duplicated. Non-key value may not be distinct. Okay. So this is the cluster. Means sum of records having a common value. Okay. So sum of records, that means for each and every record we are not going to create the index entry. So index entry are only created only the distinct value. Okay. So we can create clustering index. We can create cluster index to speed up the retrieval of records from the data file. Why we are using this cluster indexing? To speed up searching. So cluster indexing is used to speed up retrieval operation. This clustering is used to speed up. It is used to speed up. Retrieving or accessing or retrieving records from data file. So to speed up, we are using cluster indexing. Okay. So your main data file is inserted on some non-key attributes. So main file, your main data file are sorted on some non-key attribute or non-key value. Okay. So it is used to speed up the access or retrieval operation or retrieving records, and the main file are sorted on some non-key attributes. Here index file is created by non-key value. By a non-key value. So index file is created by a non-key value. Means non-key value index file is used for non-key value. That means for each record data file, index entry is not created. Okay. So index entry is not created for every record in data file. Okay. So index file is not created for every record in data file. So that is not dense indexing, but it is sparse indexing. That is sparse indexing. So here in cluster indexing, why we are using cluster? So cluster is used to speed up the retrieval operation. Cluster is used to speed up retrieval operation. And your main file are sorted on some non-key attribute. Okay, and index file is created also by some non-key attribute, and it is a sparse indexing. Okay, so again we know in index file what happens? There is two fields. In index file there are two fields. This is the index file structure. Here the key is non-key value, and this is the block pointer. Okay. So this is the non-key attribute, and it is the block pointer. So this is the structure of index file. Index file in cluster indexing. Okay, this is the structure of index file in cluster indexing. So ordering field of a data file have a distinct value for each record. Okay, ordering of records in data file have a distinct value for each record. That means it includes one index entry for each distinct value for the field. So if you are using non-key attribute, same value can have number of records. So for all records having the same value are not created for each index entry. So only index entry will be created only once. Okay, index entry will be created for only once. For that one pointer, that will give the location for number of records. So that it is sparse indexing. It is not dense indexing. Okay, for some of records we are using a common index entry. Okay, some of records we are using some common index entry. So this is sparse indexing. This is not dense indexing. Okay, that means there will be only one entry for each unique value of non-key attribute. Okay, for every non-key attribute we are using only one entry. So if non-key attribute, there are suppose 5 number of non-key value, 5 different records. So for 5 different records we will create only one in index entry. Okay, so average number of block access required equal to log n base 2 plus 1. This is the average number of blocks are required. Average number of blocks are required in cluster indexing mechanism. Okay. So there is a one entry in the cluster index for each distinct value. There is for each distinct value one index entry will be created. Okay. So for distinct value of the clustering field containing that value and a pointer, just as we are using in the structure of the index file. So in index file only a non-key attribute, non-key value will be used, and there is a block corresponding block pointer. So this non-key attribute must be distinct in index file, but this non-key attribute may not distinct in main file, because number of records in index file must be less than number of records in main file. Number of records in index file will be less than number of records in main file. So that means for each and every record of the data file, index entry is not required because we are using clustering. means by considering, by gathering similar records having a common non-key attribute on which it is subject. Okay. Suppose 5 the number of records having a common key attribute, then that for that non-key attribute will be used only once in index file. Okay. So for example, we are considering the name, we are considering the address. So same address or same district. So we are considering student list district. So for same district we will create only one value in index file, but for the same district number of records will be in the main file. So this is the mechanism of the cluster indexing. Now let us discuss a example to provide the cluster indexing. Now and the example of the cluster indexing. Example: a cluster index on suppose department code ordering field on the employee. We are considering a employee record, a cluster indexing on a non-key attribute, that is department code in a employee database. So here non-key attribute, that is department code. Department code is considered the non-key attribute because department code will common for all employees working in the department. Okay. So this the database may contain department number, department code, name and salary suppose. So department number, name and salary. This is the main data file. This is the main data file. Okay, this is the main data file. So here, suppose department 1 or department 1. This is the block 1. This is block 2. This is block 3 suppose. Block 4 and so on. And so on. In this way, there are so many number of blocks in the data file. Okay, there are so many number of blocks: block 1, block 2, block 3, block 4. For each entry in the main data file will create the index file. So this is the main file. Now we are creating the index file. Index file. So index file will be created according to the non-key attribute of the data file. So here department is the non-key attribute. It is the non-key attribute because for 3 employees there is a 3 employee there is a common department code. The 3 employees working in department 1. So in index file, in index file, clustering field is the index file. So index file is department code, and this is the block pointer. So here clustering field is department code. So this department code is the clustering field. This is the clustering field. So department 1, this is the pointer. This is the anchor record. Okay, this is the department 1. Similarly, department 2, department 3, department 4, okay, department 3, department 4, and so. So this is the department 2. Index entry for this. Department 4. Index value will be created for this. Department 4. Index value will be created for this. So there are suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 number of records in main data file. Okay, so 12 number of records in main data file. Also we can create another one. Suppose this is the block file. So in main file there are how many number of records? 5 into the 15 number of records. 15 number of records. Okay. So 15 number of records are stored in main data file. So all are recording sorted. Okay, all are sorted. This is the cluster indexing. All are sorted according to the department. All records are being sorted here according to the department number. So department 1, department 2, department 3, 4 and 5 and so on. So 15 number of records are arranged in a orderly in main data file. So while we are creating the index file for this main data file, only we have to create the 5 records. Only we are creating the 5 records. And for each record, each and every record, index entry is not created. So instead of using this 15 number of records, only 5 records are having index entry. Okay, only 5 number of records are having index entry. Okay, so in index file there is 15 number of records, but in index file there are 5 number of records in index file. Only in index file there are 5 number of records are being created. Means 5 index entry are created to create the index file. Okay, that means a cluster index is a special type of index. It is a special type of index that reorder the way records in the table. They are physically stored. So in physically these records are stored in this way. But in case of file creating the index file, we are creating in this way. So number of records will be less in case of cluster indexing, because to a particular non-key value we are creating a cluster field, cluster in the field. Okay, cluster in the field. So it can have one cluster index, because number of records for each and every record in data file are not required to create a index entry in index file. So this is not dense indexing. this sparse indexing, because index file is created only to some distinct key value, distinct non-key value of the main file. So this is one. So for three different department code, we are creating single entry. So here, in case of cluster indexing, this is distinct. 1, 2, 3, 4, 5. We cannot put here 2. Okay, because this cannot be duplicated in case of index file or while creating the index cluster. So with the cluster index, the rows are stored physically on the disk in the same order as the index. At the same order, just like this, we are arranging 1, 2, 3, 4, 5, 6. Same orderly, 1 for all records in 1, then all records 2, then all records for 3, all records for 4, and all records for 5. Same order will be considered same for our convenience. So it is generally faster to read from a cluster index while to get back to all the columns. Okay. So in this way, the search operation will be more faster. The search operation will be more faster. By using this cluster indexing, the searching operation will be faster, because for each and every records of the main file are not required to be created for index entry, because index entry is created only to distinct value. Okay, so these three records are physically stored in secondary storage device or main data file. So for three records having common department number are not required. For three index entry are not required. Only index entry is only one distinct value. So here this is our distinct value 1. So 1 will be indicated for all these values. So the block pointer gives the location of the first record having same cluster field. So here the cluster field is department 4. So one in index file, this field will store the pointer, block pointer that points to the first record. Okay. Similarly, for second one, the cluster the index entry is not required, and for third one, index entry is not required. Whenever the second, this is distinct value. Okay, so index record is created. For this one, second one, so index entry is not created because already index entry is there. For third one, index entry also not required. Okay. For seventh, 1, 2, 3, 4, 5, 6. For seventh record, index file is required because this is the distinct value. For eighth record, index value, index entry is not required. For this one, index entry is not required because this is duplicated. Whenever I coming to here, this is 10th. This is the 10th record. For 10th record, index entry is required because 4 is the distinct value. For 11th record, index entry is not required. For 12th index value, index entry is not required. Then whenever coming to here, this is 13, 12, 11, 12, 12, 13, 13 record, index entry is required because this is distinct. For this one, index entry is not required. For this one, index entry is not required. So in this way, we are creating the cluster field. Okay, to search faster. So in case of primary indexing, what happens? The index file was created by considering a key value, but this is sorted. But in case of cluster indexing, the index file will be created according to non-key value. Okay. So here also main data file is sorted. Okay. So data file is both sorted in primary indexing or cluster indexing. What difference is that here index file in cluster indexing, we are clustering to a field means by considering the non-key value, because the possibility of this value will be duplicated in main data file. This is the difference. In case of primary what happens? For primary indexing, for each record of the data file has required the index entry in index file. That means number of records in data file was equal to number of records in index file. But here number of records in index file is less than number of records in main file. Okay, so number of records in index file and main file was same in case of primary indexing, because for each and every record of data file is required to be created an index entry. But in case of cluster indexing, this is not required. Only index entry is required only for distinctive value of main data file. So in cluster indexing, index entry is required only for distinctive value in main data file. So this will be faster. So index value will be less as compared to primary indexing. Okay, so in primary indexing, number of records in data file was equal to number of records in index file. But in cluster indexing, the number of records in main file is greater than number of records in index file. Okay, so that searching operation will be faster. So in this way we are using the cluster indexing. Okay, in this way we are using the cluster indexing. So follow this concept, and the corresponding description or note will be sent on your group. Okay, follow in this way. If you will doubt, you can ask me. Okay, thank you.